start showing you what I have and just start right off. And I just want to put this, provide some context here. I'm going to highlight some key areas where we need both policy and technology innovation to meet the state's net zero targets. I think that's going to become much more important given the election results. I assume we will be pulling out of the Paris Accord when Trump becomes president again. And so what New Mexico does is very important. And so this is just to show you, and this is stunning to me. This is Elephant Butte in 1994. This is Elephant Butte in 2013. And 2013 is a while ago, so I wanted to see if it had changed. So this is what I could find on 2019. That's the water level decline, and there's a large boat over there on the right. So it is continuing, just showing you the impacts of climate change. And the world is responding to the impacts of climate change. These are the number of nations, states, regions, cities, companies that have net zero targets and what has happened in 2.5 years, okay? And you can see there, nations, 20% increase in 2.5 years, 76% of all countries, 99% increase in states and regions, cities, 63% increase, and importantly, companies, 123% increase. That's important because that includes, those companies include a lot of investment firms. And so they have, those investment companies have net zero targets. It affects what they invest in. I'll say a little bit more about that in a minute. These are, as of July 2024, a net zero coverage, 88% of the world's emissions, 93% of its GDP, 89% of its population. And so turning to New Mexico, this is our state rankings. We are 7th in the nation in wind generation, 3rd in the nation in total energy production, 2nd in the nation in total oil production, 6th in marketed gas, 48th in gas prices, and 37th in CO2 emissions. And this surprised me. I've only been doing this job since May. And our largest source of power generation in New Mexico is wind. Next is natural gas. That's still 59% fossil generation. That 21% coal, that's declining very rapidly. That's 2023. I'm sure that coal's already gone down. But what this shows you is New Mexico has significant renewable, clean energy resources and conventional energy resources. And so how we transition could set a model for the country and the world. And that's one thing that I'm really focusing on. And this is where our emissions come from in New Mexico. And again, this is 2020. It was the most recent I could find. We need good data. In New Mexico, we need to improve that. 53% of our emissions are from oil and gas production. And so we need innovation and we need policies to diminish that dramatically and fuel switching if we are going to meet our net zero targets. So I'm going to switch to electricity here and talk about electricity. What you see here, the red is total system LCOE, so dollars per megawatt hour. Green is the levelized capital costs, and the navy blue is capacity factors. And I don't know how many of you reside in the world of capacity factors. I do. Combined cycle, that's 87% capacity factor. So you're getting, when you're generating electricity, you're getting electricity 87% of the time. Okay, go around to the different, so those are your base load. Here's your intermittents. So you look here, solar standalone, cheaper LCOE than natural gas combined cycle, but its capacity factor is 29%. Okay, and so you got to build over twice as much, almost 3 times as much solar standalone to get the same actual power generation. Onshore wind slightly better, capital cost also much higher. Those are your resource constrained intermittents. Battery storage, $128 per megawatt hour. Okay, so that's important. I'll show you why in a second. Energy too cheap to meter. I read this in New York Times and I read it all the time. Wind and solar are cheaper than gas and coal. Not if you look at capacity factors, and you need to actually include the cost of battery storage, which is very, very expensive. Okay, and so that's hugely important. We need innovation to get those costs down. And what you're seeing here, EFI did a study of California. It was a technology study, not a policy study. What technologies did California need to meet its clean energy targets? And what you see there, the blue is wind, the red is solar, and the number of days in the year, in 1 year, and these are data, actual data, not modeling. In 1 year, California had 90 days with no wind. It had 10, 11 days in a row with no wind. And so our conclusion was, absent long duration storage, you need a fuel. Okay, and California is adding a lot of battery capacity, but it had in 2022, 203,000 gigawatt hours of power generation, 15,400 megawatt hours of large battery storage. So again, it's working to address the 90 days with no wind with battery storage. It's got a long way to go. Battery storage is very expensive. We need huge innovation and work on battery storage. This is also electricity, and what I'm showing you here, and very important to the state of New Mexico, which has a water scarcity, is the water use and gallons per megawatt hour for the different technologies, generation technologies. And that's the different phases: fuel production, operations, and plant infrastructure uses. And so what you see here, and these are important for New Mexico: blue hydrogen, gas with CCS, green hydrogen. I should have marked geothermal. We need to be doing a lot more on geothermal. We're not. Natural gas without CCS, solar PV, and wind. So solar PV and wind use very little water. I would say that concentrated solar, when you look at that as opposed to solar PV, it's the highest water consumption of any of the technologies that I have on here. But important for New Mexico and interesting, when you look at natural gas with CCS versus natural gas without CCS, it adds roughly 160 gallons of demand for water per megawatt hour. Okay, so CCS uses more water than I thought. It also, I've got the numbers there for blue hydrogen. So that's what makes blue hydrogen more water intensive than green hydrogen, is the CCS. So we need to be paying a lot of attention and doing partnerships on reducing water use for power generation and, quite frankly, reducing water use for CCS. Because IEA has said, and this is an International Energy Agency, a direct quote, it's virtually impossible to reach net zero in the world without CCS. So we need it, we need it in New Mexico, but we need to reduce the water consumption. This is forecast for electricity demand for data centers. This was shocking, and it's in a McKinsey scenario, but it's their medium scenario. Terawatt hours of energy consumption for data centers: 2023, 147 terawatt hours; 2030, in 7 years, 606 terawatt hours. And as a share of total US power demand, in 2023, 3.7%. It goes to 11.7%, almost 12% of our power demand in 2030 is for data centers. So another area we need to be focusing on is reducing the electricity consumption of data centers. I would also suggest that we need to be thinking about on-site power generation for data centers. The issue there is our regulatory structures don't support that. So a little more on electricity. This is how our distribution systems used to work. one-way flows of electricity, 3 customers, industrial, commercial, residential. So one-way flows, you can see I did this because it's Kenderdine utility up there. Okay, so I made this slide, but that's how it used to work. This is how it's working now. So, you know, two-way flows of electricity, multiple customers, and importantly, our distribution systems are now communicating with our transmission systems. You can see there on the upper right. And that raises a lot of energy security issues and electricity security issues, cybersecurity issues. Last time I looked, there were 5 to 6 billion unhardened devices communicating with the world's grids. So it's really a cybersecurity issue that we need to be working with our labs, our academics, our utilities on minimizing the cybersecurity risk. I know there's a lot of work being done on that. That's good. We need more of it. This is a scenario, a Connected West study. Okay, you can see there, and it's a scenario, and this is for 2045 generation additions. It's a very thoughtful and substantial study that we need to pay attention to. Those are generation additions, so you see a lot of yellow is solar, blue is wind, a lot in the West of wind and solar generation additions. And a lot of transmission line needs that we're going to need by 2045. This is looking at New Mexico. Again, a lot of wind and solar, a little natural gas, and a huge need for 345 kV lines and 500 kV lines for moving our wind and solar around. We're exporting a lot of it. Here's a problem with that. This is a conventional energy timeline, South Fork wind permitting timeline. And you're seeing there, you've got 7 different requirements that you have to work with to get this line up and running. One of those, the Outer Continental Shelf Lands Act, is almost 3 years. These are occurring simultaneously, but it's expensive, it's time consuming, and what you saw there is 3.1 years to get to construction, 7 different reviews, almost 5 years from start of the process to the end of construction. So we need all of that wind and solar, we need the transmission, but it's taking a huge amount of time. This area needs an enormous amount of focus that we should be working on together as well. And what you're seeing here, it's for conventional and clean energy resources, gas pipelines, 5 years, and electricity transmission. The average time in the country is 7 years, and you can see people want clean energy, but they oppose the transmission lines. So it's a problem we've got to work on. It's a political problem too. This is another issue associated with those transmission needs. It's not reality, but it's a reference frame that I did based on reality. EIA, I could only find 2016 numbers. It took me a week. 160,000 miles of high voltage transmission lines. They need to update their data. Okay, that's another issue. Princeton Net Zero says in one of its scenarios, the U.S. needs to increase its transmission capacity by 75% by 2030 to reach net zero targets. I assume that 60% of that capacity is achieved by adding new miles. 40% is technologies to get more power onto existing lines. Another area where we need to be working as a team, and your consortium needs to be focused. 60% of 96,000 translates to 72,000 miles of new high voltage transmission lines by 2030. There are 5 to 5.6 towers per mile. We need 360,000 towers by 2030. Those are made from steel, aluminum, and copper, among other materials. So are transmission lines, so are wind turbines, so are cell towers, so are EVs, so are EV charging stations. There are several points here. We need a lot of aluminum and steel. We need it by 2030. We need mining. I'll say more about that in a second. There's a lot of competition. Prices could go up. We need the manufacturing capacity, and And we're not going to be able to get net zero aluminum or steel by 2030. So I think in the end, we're going to need CCS, and I'll say more about that too. I'm going to switch from electricity to industrial uses. We spend a lot of time focused on electricity and not enough time on the industrial sector. What you're seeing here, and this is US, okay, is the percentage of fuel used as a feedstock or for the heat you need for key industrial processes. So food, at the top line is 2019, bottom 2050, top bar, 50% in 2019 of the fuel we needed to make the food that the world relies on. We are very important for food security, is natural gas in the United States. And the rest of the world, a lot of it's coal or oil, but here we've got abundant gas supplies. Approximately 24% is electricity. So that fuel number does not include electricity, which is the yellow bars. Glass, critical for solar panels. 87% of the fuel is natural gas. Aluminum, 47%, 45% electricity. Bulk chemicals, very important for making wind turbine blades. I'll show you more of that in a second. 45% gas. Importantly, 35% is petroleum products for those chemicals. Iron and steel, 30% gas, 52%, that is coal. Okay, so we're using a lot of coal and gas for iron and steel that we need for the towers I showed you earlier. Refining, again, important for the wind turbine blades, approximately 30% gas, 45% petroleum products, a little electricity. So bottom line is, I said earlier, we need a fuel. We need a fuel here in the US, that's natural gas. And we need these for the technologies that we need for the clean energy transition by 2030. I mentioned wind turbine blades. They're basically made with oil, glass, and carbon fiber. Okay, but importantly here, the third stage, second stage and third stage, 1700 degrees C, 2800 degrees C. Electricity gives you maximum 400 degrees centigrade. So another huge area of innovation focus. How to get green steel and reduce the and other options for high heat from electricity. I know there's a lot of focus on green steel. We need a lot more than that. But also the conclusion is, again, you need a fuel for this. In the US right now, that fuel is largely natural gas. In the longer term, it could be hydrogen, but we need a fuel, and it raises issues about CCS. I'll say a little bit more about that in a second. And even where you can electrify the processes in these industrial processes, this is the difference in the natural gas prices for industry versus electricity prices for industry in the United States. On a per unit of energy basis, electricity is 513% higher. So we've got to be mindful of our the competitiveness of our industrial products as well when we're looking at these kinds of numbers. So I'm not almost done here. I got to go very quickly. I only have 7 minutes left. This is a map. It's an overlay of two maps. It's electricity regions in the United States. So the West Coast green there, that is an electricity region, Pacific contiguous. And the other map are potential sequestration sites. So look, going around the country, New Mexico's in the mountain region in these electricity regions, and 69% of the power generation, that's 2019, it might have come down a little, is gas and coal. Okay, that you're seeing jobs associated with that as well. The highest gas and coal is West South Central, 71%, lowest Pacific contiguous, 36%. That's because they have glacier-fed hydro. The glaciers are melting in that region, so it's going to be a problem in the future. And you can see the sinks there, oil and gas reservoirs red, unminable coal seams, saline formations. Look at the saline formations in New Mexico, important for a lot of reasons. I'll say a little more about that in a second. This is where your cement plants are. Okay, these are emitters of carbon, what I'm showing you here, that could be at some point in the very near future use hydrogen as a fuel. Right now, they're using different kinds of fuel, but they also are huge carbon emitters. That's where your steel plants are. That's where your refineries are. Important for New Mexico in the Northwest and the Southeast. A lot of gas processing units, large emitters of carbon, and that's where they all are. And so this says a couple of things. You need CCS, and we need to be thinking very carefully about the transition and how we could be using hydrogen in lieu of natural gas for those fuels as well. And so we need CCS and we need hydrogen. I've read a lot that we don't have. CCS is not ready for prime time. That's nonsense. These are in the world operational CCS projects under construction in advanced development and in early development. So a lot of operational projects have increased 58% in that 3-year time frame. Advanced development 670%. So the world is banking on CCS. It is ready for prime time. You've got operational. Important for New Mexico, I showed you gas processing. The operating by type, okay, gas processing is 13 out of 30. So we need to be looking at capturing carbon from gas processing units. Very, very important for New Mexico, important for the world. Advanced development, a lot of focus on hydrogen and power generation. Class 6 primacy, this is an example of a relationship, contractual relationship the state has with a university. And this is what New Mexico Tech is doing. Class 6 primacy is to give the state primacy so that the state is regulating underground CCS underground based on and following the Clean Water Act. So the state's going to be doing that. And you can see we're in the pre-application phase. New Mexico Tech, we are working with New Mexico Tech on these research and planning needs, rule development needs, stakeholder engagement, et cetera, and legislative changes that we need. So this just provides you an example. I've said CCS is hugely important. New Mexico has great subsurface opportunities for CCS and an example of where we're working together. Switching gears here, this is a value of New Mexico's produced and brackish water. You saw those saline aquifers. And we need water for hydrogen. We need it for clean hydrogen, green hydrogen and blue hydrogen. We need it for CCS, but we're water short. We have an estimated 4 million barrels of produced water per day. We're disposing of that. Up to 150,000 acre feet of produced water on an annual basis could be treated. And this is an area of research that we need. We need to clean up that brackish water in inexpensive ways. And according to the governor, Strategic Water Supply Initiative, diverting just 3% of produced water disposed of in injection wells to make hydrogen could power 2 million homes in New Mexico annually. We need a lot of work on this. We need to be working with academia and your consortium about how we affordably clean up that produced and our brackish water that we have in those saline aquifers, but we need to do more on that. And switching gears again, we need huge amounts of metals and minerals for clean energy technologies. And the New Mexico, this is a list of metals and minerals found or produced in New Mexico, what they are used for in the clean energy space, and where we're importing them from to. All of these are on the USGS critical list. So you can see here, antimony, 63% of we are importing is from China. We're 100% import dependent, okay, or 81% import dependent. 63% is coming from China. So making glass and steel hugely important for solar. Manganese for steel. 69% of that manganese is coming from Gabon. We are 100% import dependent on imports for manganese, and then rare earths to make glass for solar wind turbines. 80% of that's coming from China, and we're 100% import dependent. So we have these in New Mexico. The mining industry has a terrible reputation. We need to be working on that. I have proposed that we develop a lead-like standard for mines. Would love to work with your consortium on what would figure into that, but you can see we need these. We're importing these from around the world. Global shipping emissions are only 3% of emissions, but that's 3% in a net zero world is a large amount. And we could create jobs, et cetera, here, and help contribute to the clean energy transition if we develop them here. Copper's not on the clean energy, it's not on the USGS critical list. They are working, trying to get on that list. I just toured the copper mines in New Mexico, but this is information about copper. You see there a copper content by vehicle, internal combustion engine, 48 pounds of copper, an electric vehicle, 183 pounds of copper. We need huge amounts of copper. New Mexico has it. You can see down here in 2020, the entire global demand for clean energy copper uses was 1,000 kilotons. 2030, 1,400. China will require 1,400 kilotons alone. The EU, 1,000. The US, 700. So we need copper. And because of that competition, this is what's happened to the price. It's doubled in 4 years. I looked at the IEA's. I'm sorry, going over. I just have a couple more slides. IEA's sustainable development scenario says we need 140 million EVs by 2030 at 183 pounds of copper. That's 11.6 million metric tons of copper by 2030. The entire global production in 2020 was 20 million. So New Mexico needs to develop its copper. We desperately need it for clean energy transition, and there's a lot of competition. You can see there what we're using it for. So developing the mining standards, clean energy mining standards, in my view, is hugely important, and developing New Mexico's resources, including copper and other resources. You all know about the Breakthrough Energy Law, the infrastructure bill, and CHIPS. This is the areas you're seeing here, broken out. Loan authority, 390 billion. This is DOE only. Tax credits, 271 billion. Direct spending, 194 billion. New Mexico has received 5.9 billion from these and other related funds for clean energy infrastructure and manufacturing. My office is implementing about around $1 billion of that. And so we need to be working together on very effective and important implementation of that funds. This was a little shocking to me. Company climate technology funding, at the same time we're getting huge government funding, has been reduced by a half. In third quarter 2022, $40 billion. Third quarter 2024, this is actually it's 4 times less. In 2024, it's only 10 billion. So we need to be thinking about incentives for business as well. And then just a couple more points. We have huge needs by 2030. I showed you what we need by 2030. We're getting a huge amount of investment dollars. These are the timelines for development of key energy technologies. Lithium-ion rechargeable batteries globally, 27 years. And the blue is invention, development, and demonstration. The yellow is market deployment and commercialization, showing you, and so you see nuclear power, 39 years in France, wind, 40 years. I read a lot. Combined cycle gas turbines is 45 years, solar PV, 55 years. I hear a lot about it happened overnight. That's nonsense. We also need to focus on how we can accelerate the timelines for these critical technologies, because 2050 is 25 years away. And this just is, I think this is the second to last slide. We did at EFI an analysis about what technologies we needed for the clean energy transition, what we should focus on, analyzing key drivers, development, selection criteria, technical merit, market viability, compatibility, consumer value. We need to be doing this analysis in New Mexico. Universe of emerging technologies, innovation areas with significant breakthrough potential. What we came up with was storage and battery technologies, advanced nuclear reactors. I think SMRs could be very important. On-site generation for the what I mentioned, the data centers I showed you the earlier. Technology applications for industry and buildings difficult to decarbonize. We discussed that. That includes hydrogen, electric grid modernization, smart cities, and deep decarbonization and large-scale management. So CCS and quite frankly, direct air capture, and how these compare the DOE's Earth shots. They've got hydrogen shots, so hydrogen, long duration storage, consistent carbon negative, very consistent with what we came up with. I think they copied us. Enhanced geothermal, we didn't look at that. We need to do a lot more of that. New Mexico said that earlier. Floating offshore wind doesn't matter to us. Industrial heat, hugely important, as I discussed. Clean fuels and products and affordable energy. And we are doing a lot of that at EMNRD. Appliance efficiency standard incentives, solar for all, and home energy efficiency. And so this is the last slide. I am proposing, and I would love to work with you all on this, and I have a tentative sign off to move forward on the first phase. At the DOE, when I was there in the Clinton administration, Obama administration, President Obama, via executive order, instructed the government to do a quadrennial energy review. It was 22 agencies of the federal government, all of which had equities in the energy sector. My office did the analysis. DOE led that. We coordinated it and did the final product, but worked with 22 agencies doing a QER. We did installments, so we wouldn't have an 800-page document on the table that no one read. So we did installments. The first one was infrastructure. Second one was electricity. Had we been able to do the third one, Trump was elected president then, and so it died. He killed it. But we would have done supply chains. I think for all the reasons I've discussed, we need to do something like that in New Mexico and make us the shining star on the hill in the coming days because of our clean energy and conventional energy resources. Could be very, very instructive, helpful for here, instructive for the world. 3 areas of focus: energy security, reliability, resilience, enabling a clean energy future, and then affordability, economic value. And that would be a comprehensive clean energy transition strategy, cross-cutting issues, innovation, infrastructure, investment, incentives, and inclusion. I like to be cute, all the I words. Here's more cute. And these are the analytical areas. And again, I'd love to work with you. Climate change mitigation, clean energy, collaboration, conservation, all C's, affordability, acceleration, adaptation, allocation of resources, all A's, reductions, reliability, recycling, resilience, repurposing, et cetera, all R's, decarbonization, technology, design and markets, deployment, all D's, and sequencing, supply chain, siting, safeguard, standardization, services, et cetera. I would call it CARDS, CARDS, and to reach net zero, we need to play our cards right. So that's, I know I've gone over, I apologize, and but a lot to say, a lot of things that I think we could be working with you all on, areas where we are focusing, and love to work with you, and excited about this opportunity. So thank you so much. Hello? Okay.
Thank you so much, Secretary Kenderdine. I think we have also, so in the audience, we have NMSU, UN, we have NMSU, Los Alamos, Sandia, NMT, represented.
Can I say something about, and I didn't mention it, about, and this I think could be very, very important for NMSU, and it has to do with hydrogen, that and borderplex. And we currently price hydrogen as a specialty chemical. It's bilateral contracts between two entities. We start using hydrogen as an energy commodity. We have no pricing mechanism for using hydrogen as an energy commodity. We need an index. And I think the perfect place to start doing the analysis and work to develop that index is in the borderplex area where NMSU is, because we need an index like WTI or Henry Hub. We need to start developing that for hydrogen, and it's close to where we are producing hydrogen. It's 2 countries, it's several states, and I think it could be a very important analytical project. Sorry, I meant to say that. So I took even more time. So sorry.
I see that's very on point to discuss this right now, and because we have the people in the room, and I think we should continue the discussion with the same actors from all the university and national lab and the state also. So we just discussed that with Dr. Henley from Sandia, that we need to have this type of meeting more regularly with all the universities in the state and in the national labs to leverage what we do, and also with the state, but the utilities and all the existing partnerships. So we have people from PEDA, the Permian Energy Development Lab, the Four Corner Energy Alliance. We have also the utility with PNM in the room. So thank you very much, Secretary, for the presentation.
Thank you. And I would love to have a working meeting with all of those entities, okay, to see how EMNRD and the state of New Mexico could work with you all on a lot of the issues and other issues I discussed. So, okay.
Sounds amazing. Thank you very much again.
Thank you. Bye-bye.